Beneath the waves, a secret network hums with activity, carrying over 99% of international internet traffic. This is the story of the undersea internet cables, a marvel of modern engineering that spans the globe. Over 1.2 million kilometers of cable crisscross the ocean floor, connecting continents and powering the digital age. The first transatlantic cable was laid in 1858, stretching over 4,000 kilometers from Valentia Island in Ireland to Newfoundland in Canada, a distance that was previously unimaginable for real-time communication. This pioneering feat was the brainchild of Cyrus Field, an American entrepreneur who envisioned a network of underwater cables that would revolutionize global communication. The cable was made of copper wire coated in gutta percha, a natural latex sap that provided insulation and was capable of transmitting a mere 10 words per minute, a slow but significant start to modern telecommunications. The project was a massive undertaking, with over 300 men working on the cable ship HMS Agamemnon, which laid the cable at a rate of about 100 miles per day. Despite initial technical difficulties, the cable was finally completed on August 16, 1858, and the first message was sent by Queen Victoria to U.S. President James Buchanan, marking the beginning of a new era in global communication. The success of this project paved the way for modern undersea internet cables, with over 400 active cables spanning the globe today, transmitting vast amounts of data at speeds of up to 100 gigabits per second. The advent of fiber optic technology in the 1980s revolutionized the undersea cable industry, enabling the transmission of vast amounts of data at incredible speeds. The first fiber optic cable, TT-8, was deployed in 1988 with a capacity of 40,000 telephone calls simultaneously, a significant improvement over its copper predecessors. This pioneering cable paved the way for modern undersea cables, such as the Maria cable, which spans over 6,600 kilometers from the U.S. to Spain, and the Asia-America Gateway, which connects Southeast Asia to the United States. These modern cables can transmit an astonishing 160 terabits of data per second, equivalent to streaming over 50 million high-definition videos simultaneously. Companies like Google, Facebook, and Microsoft are investing heavily in these undersea cables, with over 400 submarine cables currently in operation worldwide, covering a distance of over 1.2 million kilometers. The impact of fiber optic technology on global communication has been profound, with over 99% of international internet traffic being transmitted through these undersea cables, making them a vital component of our digital infrastructure. Laying undersea cables is a complex and delicate process, requiring specialized ships and equipment, such as the Maersk Connector, a state-of-the-art cable-laying vessel. The cable is fed off the back of the ship, guided by a system of pulleys and winches, and laid onto the seafloor at a rate of up to 200 kilometers per day. This process demands precise navigation, as the ship must chart a course through treacherous terrain, avoiding underwater mountains and valleys, to ensure the cable remains intact and functional. For instance, the Asia-America Gateway cable, which spans over 20,000 kilometers, had to be carefully laid across the Pacific Ocean floor to connect Southeast Asia to the United States. The laying process is further complicated by the need to bury the cable in certain areas, such as near coastal regions, to protect it from fishing gear and other hazards. According to industry estimates, over 1.2 million kilometers of undersea cables have been laid globally, with companies like Google and Facebook investing heavily in new cable projects, such as the Duna cable, which will stretch over 6,000 kilometers across the Atlantic Ocean. Chapter Modern Cable Networks, about the hidden world of undersea internet cables. Today, there are over 400 undersea cables in operation, with many more in development, spanning a total length of over 1.2 million kilometers. The Asia-America Gateway cable, for example, connects Japan, the Philippines, and the U.S., while the seabed cable links Brazil to the U.S., with a capacity of 40 gigabits per second. The Maria cable, a 6,600-kilometer-long cable, connects the U.S. to Spain and is capable of transmitting 160 terabits of data per second. These modern networks are designed to be highly resilient, with redundant systems and backup paths to ensure uninterrupted service in the event of a cable break or outage, which occur approximately 200 times per year, often due to fishing and shipping activities. Companies such as Google, Facebook, and Microsoft are investing heavily in these undersea cables, with Google alone investing over $3 billion in the past 5 years, highlighting the importance of these networks in today's digital age. Chapter Security and Maintenance, about the hidden world of undersea internet cables. Undersea cables are vulnerable to damage from natural disasters, such as hurricanes and earthquakes, with over 200 cables damaged or destroyed in the past decade alone. Fishing gear and anchors also pose a significant threat, with around 70% of cable damage attributed to these causes. Furthermore, there is also the risk of sabotage, as seen in the 2013 cutting of the SMEWE4 cable in Egypt, which disrupted internet services for millions of people. To mitigate these risks, cable operators employ advanced monitoring systems and maintenance techniques, including remotely operated vehicles, ROVs, that can repair damaged cables. Companies like Subcom and TE Subcom utilize these ROVs to quickly respond to cable damage, minimizing downtime and ensuring the continuity of global communication and commerce. The importance of undersea cables to global communication and commerce has also led to increased security measures, including encryption and secure routing protocols, such as those implemented by Google and Microsoft to protect their undersea cables. As we continue to rely on undersea cables for global connectivity, it's essential to appreciate the incredible engineering and technology that goes into building and maintaining these networks. Join us next time as we explore the future of undersea cables and the innovative solutions being developed to meet the demands of a rapidly changing digital landscape. Don't forget to subscribe for more fascinating stories about the technology that shapes our world.